Hello everyone. So you know very well as a programmer, time complexity, space complexity is very important. Let us assume that you made one mobile application. You downloaded that mobile application in your phone. The first thing what you are going to see is how much space it is taking. If more space, you don't download, right? Suppose you downloaded because of less space, you downloaded. But when you are opening, it is taking a lot of time. So remember, if any software performance will be calculated based on two parameters majorly. That is the time complexity and space complexity. Right? How to find out time complexity in this 10 minutes video I am going to explain to you. If you listen properly, it will be really useful to you. Let's see the first one, time complexity finding. How to find out time complexity. Right? I will explain right how to find out time complexity. Let me check. So what is the definition for time complexity? What is the definition for time complexity? Right? Definition for time complexity is nothing but the amount of CPU time taken while your program is running. The amount of CPU time your program is taking when your program is running. I'm repeating the definition again. While running, your program will take how much CPU time? That is nothing but time complexity. If at all it is taking more CPU time, right? I think it is not at all advisable. Right? It should take as minimum time as possible. At the same time, it should solve your problem also. Suppose it is taking very less time, it is not solving your problem. What is the use of it? So it should take minimum time and it should solve your problem. What is the definition? The minimum amount, right? I am repeating the definition once again. The amount of time your program is taking of CPU while running is known as time complexity. Right? If you want, I will write also. The amount of CPU time your program taking while running the amount of CPU time your program is taking while running is known as time complexity. Right? Let's see a few examples. See the first example. Main x is equal to y plus z. Main x is equal to y plus z. Right? This program will take how much time? So when this program is running, listen. When this program is running, if you observe clearly, this program contains only one statement. When this program is running, so CPU will come here. It will execute like this. It's not a loop. It will execute one time. So time complexity of this program is nothing but when this program is running, this statement will execute how many times? One time, right? So please be careful. Time complexity of this one is right one, big O of 1. If you want, you can write theta also. Theta of 1. Right? When you run this program, CPU will come here. This one statement, CPU will execute one time. So time complexity of this program, just write theta. If you want, you can write big O. Normally, people will write big O. If you want, you can write theta. This is the first problem. I hope you got it. Right? While running your program by CPU will scan this program like this. This line will execute it one time. So time complexity theta of 1. Right? Now see, some people are asking, sir, what about this then? Some people are asking, sir, what about this one? Let me check. Main x is equal to y plus z. A is equal to b plus c. Right? This is, I think if you observe clearly, this program contains two statements. Right? While running, first statement will execute one time, second statement will execute one time. Total it is executing. Right? These two statements, if you add them, 2 coming 2. Right? Remember, every constant can be written as theta of 1. Remember, every constant can be written as theta of 1. I'm writing once again. Right? 2k, 2. Right? Every constant can be written as theta of 1. 1 also can be written as theta of 1. 2 also can be written as theta of 1. Suppose assume that inside 10 people are there. Everyone is 1, 1, 1. 10 people means 10. 10 also can be written as theta of 1. Right? Be careful. Now let's see one more problem. Let's see one more problem. Mean, see this one. X is equal to y plus z for I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. If you observe clearly, listen, if you observe clearly, this program contains two statements. To be frank, this program contains two statements. To be frank, this program contains two statements. Some people are asking, sir, how? Let's see. Whenever this program running, right? Whenever this program running by CPU, first statement will execute one time. Whenever this program is running, first statement will execute one time. If you observe clearly, second statement will execute each I value. This will execute. I value 1, it will execute. I value 2, it will execute. I value 3, it will execute. So second statement will execute n time. So total time if you observe n plus 1. Total time if you observe n plus 1. Forget about small values. Bigger function if you see n, this can be written as theta of n. So be careful. Right? So total is n plus 1. Forget about small thing. Right? Bigger function is n theta of 1. If you want, you can write big O of n also. If you want, you can write omega of n also. Please be careful. This is the one more problem. Right. So let's see one more problem. Mean x is equal to y plus z for I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. Next one more, for I is equal to 1, I less than or equal to n, I plus plus, for j is equal to 1, j less than or equal to n, j plus plus, x is equal to y plus z. End of this. Right. If you observe clearly this program, it is the first statement, it is the second statement, it is the third statement. First statement, second statement, third statement. So first statement order of magnitude means first statement will execute while running one time. Second statement will execute while running n time. Third statement will execute while running n square time because each I value 1, j will execute n time. Next one, j value 1, it will execute. Each I value j is n time, every time this statement will execute. I value 1, statement 3 will execute n time. I value 2, statement 3 will execute n time. I value 3, statement 3 will execute n time, like that. So it will execute n times, right? So n times n square. If you observe clearly, total is n square plus n plus 1. Forget about small function. Take bigger one only. It is became theta of n square. So this is the way how to find out time complexity and all. I hope this will be useful to you. If you want to see all these videos, if you want to see all my notifications, please subscribe Unacademy 10 minutes engineering. It will be really useful to you. See you in the next video.